So I have here an Oildyne trim pump that's used in boats to trim up and down the stern drives. And this one is primarily used by Mercruiser stern drives. Some other manufacturers may also use them, but I'm not aware of it. So usually the problem with these trim pumps is not internal. It comes with 3 leads. One is ground, another one is for trimming up, and the other one is for trimming down. And the relays they connect to, those relays simply go bad. They may get sticky or just go bad. So you know it's very simple to swap out those relays. However, in my case, since I bought the boat not too long ago, it makes when on wide open throttle and I want to trim up, it makes a really high pitched sound, which indicates that either the hydraulic pump is cavitating because maybe the filter inside is blocked, or the air is, the oil is getting aerated, meaning that there is a seal that's letting the air be mixed with the oil. The really interesting part about this thing is, and although I have already cleaned out the reservoir, was that it was very milky, which I thought that it was contaminated with water, although the boat didn't have any external leaks. So I figured maybe the previous owner had fixed the leak but didn't change the oil, which is weird because usually what leaks are the end of the trim cylinders, and if you want to change the seals on those trim cylinders, you have to kind of get the oil out anyway. So that was rather weird. But the other symptom actually is when the aeration happens, the oil can get milky also. So now I'm thinking that I might actually have to swap out some seals inside. I really hope it's the filter, because for seals I need to get a rebuild kit, which I currently don't have. So I haven't taken one of these apart before. I actually haven't seen what's inside, but I do have official Mercruiser service manual, which actually they tell you that you can actually rebuild it. So I'm going to follow their instructions, and let's see what we will find. So the first thing we should do, according to the manual at least, is to get the bottom screw out. That is supposed to hold the whole unit together, is my understanding. So let's see if we can get it out. Given it's a US made thing, they do use imperial sockets. So let's see if one of these fits. Yeah, it's probably hasn't never been opened, so I have to be a bit careful not to strip anything here. Yeah, I can already feel the reservoir separating. So here's our, yeah, a bit of this milky residue still intact from the old previous oil. So let's see what we will see. Yeah, that's our thing. So let's put this thing aside for now. Yeah, and while you're at it, it's a really good opportunity to actually try to be careful here, to clean out any of the gunk you might have in the bottom of it, because they do have these it's baffled, so you can't that easily just get it out without having to remove the trim pump itself. So I'm gonna put this aside, and here's the pickup tubes for our oil. These are indeed filters. Doesn't look blocked to me. So as I suspected, there might be seals that I may have to get to. They can get kinked pretty easily. Yeah, they're pretty stuck, but as for the external surface area, it is quite clean, so I'm not sure if I want to remove them. So on the next things we have here are the relief valves, 2 relief valves and a thermal relief valve. And unless you have a rebuild kit, you shouldn't unscrew them because they are factory torqued to specification, and if you do undo them, they will go out of what's the proper term here? Let me quickly check. Out of adjustment, so your relief valves will not probably operate as expected. So I'm not gonna undo any of these. But if you have a rebuild kit, then you are supposed to be able to swap them out. So as suspected, I don't see anything wrong with the filters here. Although I will still try to eventually get them off and just clean them out. Okay, so let's actually now take the. Now it's making a mess on my table here. Put it back here for now. Let's take apart the. Yep, there is. Can't just put it here. There are those baffles will obstruct you from putting it in here, but we can now remove the electric motor, and I will attempt to clean the commutator. If you wonder, this socket is 5/16. That seems to fit here. Should be able to get it off. And here is our electric motor. Let me put it aside. Okay. Oops. Probably needs to go back in here. I can see I accidentally kinked my my filters also when I wanted to put it back in there in incorrect orientation. So okay, check which way it goes. So it's the wider area here. We'll put it back a bit later. Thank you. And one note about the actual hydraulic pump itself. It's not rebuildable, but you are supposed to be able to swap it out if it has gone bad. Like I said, I'm not gonna open it up because I actually don't have any spare seals to go with it. Although Mercruiser says that some of the seals in there you can actually swap over from the old pump, but I'm not gonna touch it for now. So let's see. So before I open it up and clean it, I'm gonna test which way it spins, so when I put it back together I won't accidentally mess up the polarity, so it might spin the other way. I'll get some battery leads here. So this is our ground. And if I will now apply 12 volts to it, it should spin. So this is supposed to be trimming upwards. The blue, I believe it's upwards. Oh yeah, it's quite torquey. And so it was spinning from my point of view clockwise, and I suppose you are going to be counterclockwise. Yeah, so it does work. I'm not gonna play with it. So we have to undo these 4 bolts here, screws, from the looks of it. Hopefully I won't strip any of them. We'll get these bolts away also. Yeah. This thing is probably holding up the together. Probably should be able to push you out that way. Okay, I'm gonna try to pry it open. That's only okay, have to clean it up. So we can start by moving the screws for the brushes. Just be careful not to lose the springs. Or that's, at least that's what the manual said. Take this one also. Out. Yep, that's the warning about the springs popping out. Where did it go? Here's our brush. There's a bit left. And the same thing with this one. Let's see if we can remove it without. And now the screw that holds the thermal switch. Are supposed to be two other screws here and here, so we can remove this bracket. Let's try to not the easiest thing to get to, given you this one is alright. This one, well, wouldn't want to damage any of these windings, but I think I can gently pry a little bit myself. Says here. Yeah, I don't know why they were torqued that heavy. Well, the motor is torquey, so kind of has to, you know, hold it down, but I would say that was excessive. Here's our bracket. Should be able to pull the commutator out now. There's our bushing. Hopefully I won't forget to put it back. This is interesting. There are, like, you see, this is sort of like filed off in okay, there's also a washer here. Under the bushing. So this is interesting indeed, because it's like filed off here. It's like it has rubbed against the whatever this thing is called. I can check it from the manual, but it doesn't affect the work of it. I just wonder if it throws a little bit out of balance by having these things. I don't know how well you can see it, but filed off. Anyway, we can see that our commutator here is quite, you know, there's quite a bit of carbon marks on it, which we will attempt to clean off. Now let's see if we can get the rest of it out. Yes, now we can fully clean it. And yeah, there is quite a bit of this carbon dust, I suppose. Put it here. So one of the things that the service manual gives you is the way to test if you have any shorts in your commutator, armature, or the field windings. So in my case, you saw the motor was actually working, so I shouldn't have any issues, but I'm gonna show you anyway, in case you do have a short in your motor, how to go about testing it. So the manual goes about saying, you know, use the resistance scale, but I'm gonna use the continuity, so it, you know, we can all hear when we have a continuity. So the first test is to test the between the armature shaft, this thing here, and the commutator pars. So I should just put it here, and you shouldn't have any continuity. If you have continuity, then you have a short to ground here, and you should, well, probably get a new motor. And you're supposed to do it for all of the bars here, so we can go on. Yeah, so no continuity. I probably got all of them, but even if I didn't, you know, I technically don't have any issues with this motor. So the next test is to test the continuity in the field aperture. So you should take the first of all, it says take the blue lead. In my case, this thing here. I do have them extended in my boat, but it's the blue one, and you should test if you have continuity between this lead and the this field brush. So as you can see here, I'm getting continuity, and the next thing is to test the same thing with the green lead. So this is my green here. Again, you can hear full continuity. We can move on. And the next thing is to test if there is continuity between this field brush and the, I'll give you the exact name, field frame. So I'll put this one here, and there's this part. There shouldn't be any continuity. All good. And next thing is to test if the thermal switch, I'll put it here, thermal switch is operating correctly. So the first thing is to test this part here and see if it has continuity, which it should. And then for the next test, they do have a point here like you have in an old school distributor. I have to pry the points open a little bit and put a piece of paper. I have this already dirty piece of paper here between these points. So you can see my piece of paper is between the points, and it should cut the continuity. So if I test again, here no continuity. So the points and thermal switch is operating correctly, and you can then move the piece of paper, and just in case you can double check if the contact is still there. All good. And that's about that's the tests that the official service manual gives you. For the next, I am going to try to attempt to clean the commutator here, because as you can see, it's quite well, it's not new anymore, let's put it that way. So I'm gonna start by having a bit of a toothbrush looking thing here. It's actually from an electric toothbrush, but I only need the hairs here. And I'm going to use a contact cleaner. You may be tempted to use something like a brake cleaner, but if you can use contact cleaner, because this is meant for electronics, and the brake cleaner can damage the coating on the windings here, so you might take the coating off with the brake cleaner. Again, depending on which kind of formulation the brake cleaner has, but contact cleaner is much safer in that sense that it doesn't damage rubbers and it doesn't damage any plastics. So let's see. how much can we actually remove with the brush here. And the answer is, well, not much, but I didn't really expect it to clean up that well. So the next thing I'm going to use is to use very fine grit paper. The service manual also says that you can use 00 garnet grit sandpaper. My understanding that 00 means fine or very fine grit, and they say do not use emery paper. I guess the difference here is that for example, where I live, I can easily get this sort of a sandpaper, this black one, and this one is actually quite difficult to find. And the difference is that this is made of silicon carbide, but this one is made of aluminum oxide. The difference between them is that the silicon carbide is a conductive material, whereas this one is not, and I suppose the emery paper also may leave a conductive residue on your commutator, which will probably cause more or excessive arcing. So if you don't have a choice, then make sure to clean it up really good. But in my case, I am going to hook it up with, try to use a hand drill here, so I won't have to spin it by hand. Bit of a contraption, but the idea is I can, if I balance it out, it's kind of a wobbly. So if I use it like this, I probably can balance it out on the table here. And I am going to use that piece of sandpaper on the other end. So if you are going to do it by hand, make sure to turn it only in one direction and don't go it back and forth. But in my case, I am going to try to hold it gently against it and let it use the electric drill to move the commutator. Looks pretty clean already, but there is still some left. I'd say it's pretty good. Let's now remove this contraption. One thing we need to do is we need to clean these gaps between the commutator bars, because those gaps are full of this carbon debris. Let me get the something to pry it out. So I found this plastic thingy, which is used to pry open some electronic devices, and I'm gonna use this thing to clean out all the gaps in between the commutator bars. So that's I would recommend using plastic instead of metal parts, so you won't damage anything. And this part is especially critical if you use sandpaper that is made out of conductive material, so you can get all the debris off between these from within the gaps. So probably have circled around by now. And for next I'm gonna go outside and clean all of it thoroughly using, on these parts I'm gonna use contact cleaner, but the cases doesn't matter there I can use regular brake cleaner because, you know, nothing to really damage here. Although one thing to notice about there is a O-ring here, so that's technically something you can damage with brake cleaner, so up for you to decide how you want to go about cleaning it up. Now that we have everything cleaned up, we can start putting it back together. So first we have to insert the armature back to the housing, and it's important, at least what the manual says, to make sure what's the front end of it. This is where your wires go. So your front is the part where you have this kind of usually the sticker here, and you have this recessed area here. So if you look at it, your recessed area has to stay right to you. So that's your front area. And in my case, there was some sort of RTV or glue or something that was holding this together. So I can tell by you know, by this roughness here that this is how it was put together. So first we'll put the armature back to the housing. Already put this thing here. Then we can put our sorry, it's not armature, this is field assembly actually, my bad. This is the armature. We can now put the armature back. And there, I didn't film it, but there it was also, there's the same bushing and thrust washer at the end of it. I wasn't able to remove the thrust washer, but the bushing came off, so I have to put it back here. Hopefully it won't fall out. And now we can put the bracket back in. So this is the place where the this notch here is where the thermal switch is going to attach to, so we know which way we should put it back in. And we can now put our long bolts back in here. They don't give you a torque spec, they just say torque it securely. The one who secured it before, I can tell you that it was secured very securely. Now let's secure our brush assembly mountings. Moving nicely. And finally, let's put the thermal switch back into place. Thrust washer and bushing. And we can now install the cover, or the bottom, I guess, because that's the cover. But before I do that, since I didn't have a new O-ring to put in here, I'm gonna coat it with a little bit of marine grease, because, you know, better to be safe than sorry in marine environment with these things, and chances are that nobody will probably, in the lifetime of this boat at least, will open up this motor anyway, so just a thin layer, no need to overdo it. Put a little bit for that surface area also. Underneath this rubber thingy. To here I'm going to put a little bit more because this kind of thing had to kind of rip off when I was opening it up, so I wanted to seal up nicely. And I'm gonna put some more RTV here also. Clean up the inside a little bit because I don't want to get this RTV stuck on the switch, which, you know, might prevent it from opening up when these things should get abnormally hot. I guess that's, well, I think that's the purpose of this switch here. Yeah, no parts left, at least from the motor area, which is always a good news. And I guess we can now test it again if it still works. My battery needs our black is the ground. Let's see if it still fires up. Since it's quite torquey, I'm gonna, yeah, let's try the other way around also. Does work. Hopefully also in the right direction, the way it did before, but worst case scenario I can swap the leads on the relays if it did go back to incorrectly, but I don't think that's the case. Let's now see if we can get the get these rather kinked filters off from here, so I maybe can straighten them back out. Let's see. Oh yeah, they do come off. I guess they will go back the same way. You have to be careful not to actually damage them. This one came off. Should be able to. Oh, it's quite small actually. I was hoping that I can. Well, surely I can put something in here to kind of straighten it back out. Oh yeah, well, I've broken it, so I should really swap it out. For which I really need to get the whole rebuild kit. But given that there wasn't really nothing wrong with the motor other than lots of carbon material from the brushes. And these things, as far as I can say, don't look like they are blocked either. It's either some seals inside the space plate and the pump itself, or the pump is kaput, which means, well, yeah, I haven't seen replacement parts for these, although Mercruiser says you can get one. So yeah, that's what's inside. Not much to it. There are some valves in here also, which you can get to if you unscrew the both ends. If I get the rebuild kit, then I will obviously look into here also. Otherwise, I don't want to, well, if there are any seals or O-rings, I don't want to take them apart, so because they won't necessarily seal back again. But yeah, well, that's it for now. We'll see if I can get the rebuild kit, and then we'll continue with this thing.